A humpback whale crosses an entire ocean in a dead straight line, straighter than you could walk with a compass, and no one knows how. Humpback whales make one of the longest journeys of any animal on the planet. Every year they travel between the cold, food-rich waters near the poles, where they feed, and the warm tropical seas near the equator, where they breed and give birth. That's a round trip of around 8,000 kilometers. One leg alone, from Alaska to Hawaii, is nearly 5,000 kilometers, and some whales cover it in as little as 28 days. Now think about what that actually involves. They're crossing the open ocean. No landmarks, no coastline to follow, no signposts, no roads, nothing but featureless blue water stretching in every direction, above a seabed miles below. A human dropped in the middle of that, with no instruments, would be hopelessly lost within hours. The whales just keep going in exactly the right direction. And here's the fact that stunned the scientists who first measured it properly. In a tracking study back in 2011, researchers followed humpbacks across long stretches of their migration, and they found the whales held their heading to within about 1 degree. 1 single degree, over distances of hundreds, sometimes thousands of kilometers. That is an almost unbelievable straight line. Ferries and ships with satellite navigation wander more than that. So how? We know some of the tools animals use to navigate, and whales probably have several of them. There's the position of the sun as it moves across the sky. There's the Earth's magnetic field, which many animals can sense. There are the patterns of the stars at night, and there's memory, routes learned by calves as they swim alongside their mothers on that first great journey. Any of those could help point the way. But here's the problem, and it's a beautiful one. Not one of those cues is steady enough to explain that 1 degree precision. Because as a whale swims thousands of kilometers across the globe, the sun's angle shifts. The magnetic field shifts too. Along a single migration route, both the sun's position and the magnetic field can change by more than 20 degrees. In one study, magnetic north itself had drifted by as much as 12% along the path. Do you see the trouble? If a whale simply locked onto the magnetic field and followed it, the drifting field would slowly bend its path off course by far more than 1 degree. Same with the sun. Any single cue, followed faithfully, would introduce an error much bigger than the precision we actually see. So the whales are somehow doing better than any one of their instruments should allow. The leading idea is that they must be combining several cues at once, cross-checking the sun against the magnetic field against their memory, and averaging out the errors, the way a skilled navigator uses more than one instrument and trusts none of them completely. It's a lovely theory, but, and this is the honest heart of it, no one has been able to prove which cues, in which combination, actually produce that ruler straight line. And they keep humbling us with the sheer scale of what they do. In 2026, a study in the journal Royal Society Open Science documented 2 humpback whales that had traveled more than 14,000 kilometers between eastern Australia and Brazil. That's very nearly from one side of the planet to the other. It's the greatest distance ever confirmed for the species. And the way they found that out is rather wonderful in itself. Every humpback has a unique pattern on the underside of its tail, its fluke, like a fingerprint. Researchers and thousands of ordinary people upload their whale photos to a platform called Happy Whale, which matches individuals across the world. Out of 19,283 carefully checked tail photos, just 2 whales turned up on both sides of that vast ocean gap, 2 needles in a planet-sized haystack. So let me be completely honest with you, because this is one of those rare cases where the honest answer is the whole point. We do not know how humpback whales navigate with this precision. We know roughly which tools are on the table. We know no single one of them is good enough, and we know they somehow combine them into something better than the sum of its parts. But the exact method remains one of the great unsolved puzzles in all of animal navigation. And there's something quietly wonderful about that. We have mapped the sea floor and put satellites over every inch of the ocean, and yet a creature the size of a bus, with a brain wired by nothing but evolution, can still set off across half the world, hold a line straighter than our machines, and arrive exactly where it meant to. And we, with all our instruments, are left standing on the shore, genuinely unable to explain how it just did that. So how does a humpback cross an ocean without getting lost? Honestly, it knows, and we don't. And sometimes the best answer we have is a wide-eyed, we don't know yet. There are hundreds more of these little mysteries hiding in the most ordinary corners of the world, and we are working through every single one. So stick around. Same channel, same little man, watching the whales and quietly taking notes.